Okay, 6-5, conditions for special parallelograms. So we just talked about the special parallelograms. Rectangle, rhombus, and square fall under the parallelogram category. What this does is it talks about some of the conditions. We're not going to spend a lot of time, as you notice in the homework assignment. There is no math. It's more or less filling in the appropriate vocabulary word, the appropriate understanding. It's making sure that you fully understand the difference between rectangles, rhombuses, squares, and parallelograms. Okay, so this has been building since 6-2, making sure that you understand that conditions for rectangles, if one angle of a parallelogram is a right angle, then the parallelogram is a rectangle. So if you think back to parallelograms, opposite angles are congruent, consecutive angles are supplementary. Well, if one angle is 90 degrees, that means the opposite has to be 90. And if the consecutive has to add up to 180, so 180 minus 90 is 90. Therefore, they're all 90 degrees, right angles. If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So that is identifying that the sides are straightening up. Okay, they are opposite each other. All the angles are now the same. Therefore, you have a rectangle. Looking at a rhombus, talks about if one pair of consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. If one pair of consecutive sides, then the opposite pair must also be congruent to each other, meaning that all four sides are congruent. If diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. Remember that from last section, 90 degrees is what they'll form, 90 degrees. And if one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus, which means in this case, E and G, that diagonal would also be angle bisectors. But we looked at that in 6-4 as well, just to revisit this. These are the conditions. These are the special conditions. Identifying special parallelograms, you'll notice they do, in this example, use a little bit of that formula is the distance formula. They show the diagonals. They show the diagonals are not congruent. And if the diagonals are not congruent, that eliminates a square and that eliminates a rectangle. So it has to be, in this case, a rhombus. Has to be a rhombus. Because that is what this question is asking. Is a rectangle, rhombus, or square? Since the diagonals are not congruent, it is not a rectangle, it is not a square. Therefore, we determine if it's a rhombus by showing the slopes are opposite reciprocals. Therefore, it is a rhombus. You do still have to go and prove that it is an actual rhombus. You can't just say, hey, it's not a square, it's not a rectangle. That doesn't mean it's a rhombus. It could just be a parallelogram. So you do have to go show that last step. For question B here, it gives you graph and determine the side lengths or the diagonals are congruent to each other. Therefore, you know it has to be at least be a rectangle. Determine if EFGH is a rhombus. Well, rhombus means the diagonals are perpendicular. These diagonals are not perpendicular. So it's not a rhombus, it's not a square. As we already showed, it is a rectangle. So those are the couple sort of questions, and that will be a test question as well. So remember that. Page 433, question A and B are sort of things that you will have to work through a little bit more. I know it's not in the homework, but using slopes and using distance formulas, it's just the understanding of what type of problem you are looking for. So that wraps up 6-5. Let me know if you have any questions.